In this video, I'd like to talk about two of the problems that apparently caused problems on the homework that was due last week. The first of these problems, I believe, is problem 242, which concerned the finding the grouped average. I'm sorry, 248, which concerned finding the grouped average for Geiger counter data that's given on the screen right now. The first step is to figure out the grouped average. So in this case, there were 57 times where 0 clicks were recorded, 203 times where 1 click is recorded, and so on. Then 16 times there were 10 clicks recorded. So first thing we need to do is figure out the total number of clicks that were recorded. Well, first we figure out 0 plus 0 plus 0 plus 0 plus 0 57 times. Clearly that can be expedited by just doing 0 times 57, which is 0. Then there were 203 times that only 1 click was observed. So that'd be 1 plus 1 plus 1 plus 1, 203 times. And so I can just multiply 1 times 203. Using the magic of Excel, I can just simply copy the pattern down and I get 203. This time, for the 2's, there were 383 times there were 2 clicks. So 2 plus 2 plus 2, 383 times would be 2 times 383. And then repeating the pattern for all these other products. So the total number of clicks recorded, which I can use with Excel or else by just simply directly adding them up on a calculator, would be 10,086. Okay, so that's the total number of clicks that were recorded. How many times did we record? Well, they were recorded over 7.5 second intervals, and there were, according to the problem, and this was done a total of 2,608 times. Notice that it's not 11 times. There were 2,608 times where data was recorded. And so I need to take the total number of clicks divided by the total number of observations, and that will give me my grouped mean, which is 3.867 approximately. The next step is to figure out the grouped standard deviation. To do this, we need to take the x values and minus the average. So using Excel, this would be equal to the x value minus the average, and I need to square that. And using Excel tricks, I'm going to put dollar signs in front of the around both sides of the C, so that when I fill down, that value does not move. And that would be that one particular value, 0 minus 3.867 squared. Now that's one time. That happened 57 times. So when I construct my standard deviation, I'd have this number squared plus the same thing squared plus the same thing squared 57 times. So in order to account for the fact that it happens 57 times, I need to multiply by that 57. So my new the zero's contribution to the standard deviation will be equal to that particular product. And filling down the pattern, I get the exact same thing for all the other terms. So for this last one, for example, I have 10 minus 3.867 quantity squared. Notice because I have the dollar signs, the one here in magenta did not fill down, did not move, while the ones in green and blue did move down as I filled down. And that happened 16 times, so I need to multiply that term by 16. So the sum of these things is equal to 9,472, and so therefore the standard deviation will be equal to the square root of this sum divided by the count minus 1. This is a sample, not a population, and so I have to divide by n minus 1 when figuring out the standard deviation, and so that gives me a standard deviation of 1.906. So the steps here are very similar to the other video that is on the website right now, where I figured out the grouped mean and standard deviation for the Census Bureau data. This one was actually one step simpler because the x values were given. In the other video, we actually had to figure out a quick average to figure out the mark of a class. Here there are no marks, I just have the numbers 0 through 10. And so it was fairly straightforward to figure out the x times f's and then f times x minus the average squareds. So on the other video, there is a fairly detailed write-up with actually writing out the fractions in full. And so if this quick summary, if you need a little bit more help than this quick summary, I would refer you to that other one so that you can actually see the construction of these fractions step by step. The second question that was not graded, but I heard a lot of comments about this in class, was problem 3 points. Let me make sure I get the number right. 3.41, which concerned the word statistical. So the question is, you have the word statistical, you draw two letters at random without replacement. What is the probability that both of these letters are the same? Well, to do this, first we observe that if they're both the same, then either they're both S's, or they're both T's, or they're both A's, or they're both I's. Those are the only ways that you can have two letters that are the same if you're drawing without replacement, because there's two S's, three T's, two A's, and two I's in the word statistical. Obviously, the C and the L are not repeated. I can simply add these because this is an OR question. They're both S's, or they're both T's, or they're both A's, or they're both I's. So I can add. Of course, when you add, you have to ask the question, are the events disjoint? In this case, they are disjoint. If the two letters are both S's, then they can't be both T's. So I can just simply add these probabilities together. Now, what's the probability that they're both S's? Well, this is an AND question. The first one has to be an S, and the second one has to be an S. For an AND question, we multiply. But before multiplying, we ask ourselves, are the events independent? In this case, the answer is no, they are dependent, and that's because the letters are being drawn without replacement. So the probability that the first letter is an S will be 2 out of 11. There are 11 letters in statistical, and 2 of them are S's. Now, once the first S is drawn, the chance of drawing a second S, given that the first one was an S, is now going to be 1 out of 10. And so this one term by itself, 2 divided by 110, would be this one term, the probability that they're both S's. Now I repeat for the probability that they're both T's, then they're both A's, and then they're both I's. So the probability that the first letter is a T would be 3 out of 11, because there's 3 T's, 1, 2, 3, in the word statistical. Once the first T is drawn, the chance that the second one is a T would then be 2 out of 10, because there would be 10 letters left, of which 2 were T's. Then repeating for A and repeating for I. So adding up all these fractions gives me 12 over 110, or the final answer is 6 over 55.